As the writings of Cornell Leopold and Robin Evans describe, architecture is the translation of geometry in our minds, mixed with perspective, creating a physical form in reality. This summarizes the relationship between architecture and geometry. Was it always this way? Let's go through the history. For a long time, the practice of architecture was torn between arithmetic and geometry, or in other words, Vitruvius or Euclid. Informally, both calculations of proportions and constructions were used together. Regarding this, Michel Sabaci writes, "In architecture, numbers operated for two different purposes: the determination of overall proportions in buildings and the modular construction of architectural orders." The modular constructions came from Euclidean geometry, which was primarily found verbally among workers and masons. The determinations of overall proportions in architecture was the Vitruvian method, found in his De Architectura. Pythagoras had inspired those loyal to proportions, including Vitruvius, with his fascination with proportions in the world around him. This includes harmonic ratios in music and visual elements. So, starting with Euclid, the guy who started it all, geometry. He was around from 325 BC to 270 BC, and he wrote the Elements as a combination of many other sources, compiling in a clear listing of what was known about geometry at the time. Next, we have Hippasus of Metapont from 450 BC. He discovered the golden section in his research about pentagons. Here is Leon Battista Alberti from 1404 to 1472. He mentioned Euclidean geometry in Ludi Mathematici, but he held fast to the Vitruvian tradition of ratios. Finally, we have some Euclidean geometry getting in the mix. Giorgio Martini defined line, point, and parallels according to the Euclidean definitions in his book Trattatio di Architectura Civile e Militare. Other traces of Euclidean principles also began to appear, but until the second half of the 17th century, it didn't really become prevalent until Guarnio Guarani. Architectura Civile, written around the 1670s, was written after a previous book he had written about Euclid's Elements. Michele Sabaci summarizes the impact of Guarani. He says, "Remarkably, the modular commodulatio procedure, rooted in numbers, is replaced by a mixed system where the dimensions of the architectural elements are determined by geometrical constructions and only in some cases by numerical operations. Therefore, Guarani breaks away from the long-standing tradition where the only possible way of making the orders had to be numerical." Carlo Cesare Osio is also another architect that had similar contributions. Next we have Kepler. He was alive from 1571 to 1630. He was a Pythagorean mystic, and he wrote a book called the Harmonics Mundi. Sabaci writes about another writer, Judith Field's, comments on Kepler's work. Judith Field had pointed out that the weight of the geometrical work in Harmonices Mundi must be seen as indicating that he took very seriously, him being Kepler, his endeavor to prove that God was a Platonic geometer rather than a Pythagorean numerologist. However, despite the dispute of process in architecture throughout history, it is always proved true that without the science of geometry, architecture could not exist. It is as Cornelia Leopold writes, "Geometry is located in the mind, architecture in perceptible materialized reality." Many architectural principles revolve around the concept of harmony, or the perfect balance of all forces. Throughout history, the golden section has defined the ratios of beauty and pleasing appearance. This design is found in all nature, humans, and even music. Euclid was the first to describe it as a continuous division, and he was absolutely right. So, as we can see here, we have this little square that is 1, 1. So we add another 1, 1, 1. Now we have a square that is 1 as the height and 2 as the length. So we add another square, 2 by 2. So now we have a square, or not a square, a shape that is 2 by 3. So we add a 3 by 3 square. Now we have a 5 by 3, so we add a 5 by 5 square. Now it is 5 by 8. This is very similar to how one finds the golden spiral. So, essentially, the golden section is, as Canva puts it, when a line is divided into two parts and the longer part, A, divided by the smaller part, B, is equal to the sum of A plus B divided by A, which both equal 1.618. The symbol for the golden ratio is used often as the Greek letter phi. That's what that little squiggly Y thing looks like. This golden section can be seen in very old architecture, such as the Parthenon. It can also be seen in newer architecture, such as the CN Tower in Toronto. To some architects, Euclid's dusty geometry has become snow from yesterday, if you know what I mean. So, why not turn to other geometries for structure instead? After all, as Robin Evans observed, when architects attempt to escape the tyranny of geometry, meaning by the tyranny of the box, where can they escape to? Either they must give up geometry altogether, which would be exceptionally difficult, or they escape to another, always more complex and demanding geometry, or they do the last while giving the impression of having done the first. Thus, architecture must always have some form of geometry to bring the math pictures in our heads to reality and perspective. One example is the Shell House, built in 2008 and designed by Kotaro Ide. This house used elliptical geometry for its architecture. A fascinating example of hyperbolic geometry can be found in the St. Maria Cathedral, designed by P. L. Nervi and P. Belushi. The forms of the roof are rooted in a hyperbolic parabola, cleverly forming a cross in the center of the roof inside. The high-rising, swooping forms outside and inside the church also give the impression of angel wings. Another example is the use of fractal geometry, which describes yet again natural formations of nature. This kind of geometry can be found in branches, in snowflakes, and many other forms found in nature. An attempt to mimic this mathematical order in seeming chaos was made by Lab Architecture Studio in the design of Federation Square. The most amazing thing is, geometry is found all over the architecture of creation. Plants, shells, faces, etc. show the golden ratio, and fractals are everywhere, from the teensiest cells to blazing stars. This grand scheme of order could not possibly have happened by accident. Artists have their own distinct styles, and God's distinct style is found in his nature math. The principles we try to mimic that we coincidentally discover point to a grand designer of the world. We are living in the remnants of God's perfect architecture. Thank you!